Hi, this is Roberta, and we are going to do one of our geometry learning experiences, cooler cup conversions, where we're going to explore the relationship between the volume of a cone and the volume of a cylinder. We're going to go on and dive into the content, and I'm going to get to that next station by using our next station orb.
The company is switching their water cups from regular cylindrical-shaped cups to cone-shaped cups to cut down on waste. Both kinds are 4 inches in height and 3 inches in diameter. Jody thinks the cylindrical cup can hold 3 times more water than the cone cup. Mike says the cone cup holds only half as much as the cylinder. Who's right? Let's find out. Look to your right. You'll see a water dispenser. Grab 1 cup of each kind and try putting one inside the other. That'll help you figure out how much each one holds. When you're finished comparing the cups, put your finger in the I am ready orb.
And so let's start by exploring the cones, and I can manipulate them, look at them together, and when I'm ready, I just put my hand
So,
inside the
what do
orb.
you think? Was Jody right or was Mike? Use your best guess and select your answer on the answer tablet in front of the water cooler.
Just having
All
students
right,
interact and
let's
make a
move to the next
prediction.
station to check out if you were correct. Who guessed right? Time to figure out how much the cylindrical shape cup actually holds. To figure out the cylindrical cup's volume, that's how much it holds, we'll use a formula. V equals B times H. B is the base area, and H is the height. The bottom of a cylinder is a circle. To get its area, we use pi times radius squared. Then we multiply that by the height. Boom, volume. Let's crunch some numbers. This cylinder is 4 inches in height and 3 inches in diameter. What's its volume? Enter your answer on the answer keypad on your right.
Again, pertinent information on the board, and then we're going to go and interact with our answer keypad. Again, the yellow highlight just to let us know that we have to do something. I'm going to open that calculator, and we have 4 with 3 inches in diameter. My relevant formulas are on the board.
Nice
We
work.
get a green
The cylindrical
indication I'm
shaped
right.
cup holds
If I'm wrong,
28.26 cubic inches of
this would
water.
turn
Go
red,
ahead and fill it up with
and
water from the
Watson
dispenser.
would prompt me with some hints. So now I need to fill up my cup.
Time to test our theory. Pour water from the cylindrical shaped cup into a cone shaped cup until it's filled up. Whoa, there's still more water. Grab 1 more cone shaped cup and pour in the rest. Can you fill it too? Any guesses? How much water do you think is still in the cylindrical shaped cup? Let's test it. Grab a second cone shaped cup and fill it using the leftover water. Amazing. When the cone and cylinder have the same height and radius, the cylinder holds exactly 3 times more water than the cone. Math magic. Let's head to the next station and see how these formulas are connected. Remember those 2 cups with the same height and radius but different shapes? When you poured the cylindrical-shaped cup's water into the cone-shaped cup, we needed 3 cone-shaped cups to hold it all. Crazy, right? That shows the cylindrical-shaped cup holds 3 times more than the cone-shaped cup. Looks like Jody was right. Cylindrical cup volume is equal to 3 times cone cup volume. Another way to say it, the cone-shaped cup holds just 1/3 of the cylindrical-shaped cup's volume. We already used the cylinder formula V equals B times H. Now let's figure out the cone's volume. Based on what you just learned, what factor would you multiply the cylinder's volume by to get the cones? Think about the volume relationship between them. Enter the factor you would multiply the cylinder's volume by to get the volume of the cone into the answer keypad on the right.
1/3, and we
The
have a right
cylinder's
answer.
formula is V equals B times H, and the cone's is V equals third times B times H. Remember, B just means the area of the circle at the bottom. Easy peasy. You crushed it with determining the volume formula for a cone. Now check out this cone. It's got a radius of 6 inches and a height of 18 inches. Need to work it out? You can use the 3D marker by pressing the button on your wrist and going to the Drawing tab. Select the marker and draw your steps in the air. Math in 3D. How cool is that? Use the answer keypad to your right to check your answer. Nice work.
There we
You
go.
nailed the cone's volume and figured out how
get
it
it.
compares to a cylinder
We
of the
have
same
a
radius and
celebration.
height. Math master in the making. Thank you for stopping by. This learning experience is now finished. You now have 3 options. Try more problems by selecting the button on your left, exit the learning experience using the center button, or exit to the lobby and log out by selecting the button on your right.
Okay, and we have more problems that are available that are tied to the content that is in the learning experience. If you're using it with multiple students, they would want to exit to the lobby. If you're having students do more than one learning experience, you would want to just exit the learning experience and back to the main Curio room. And this is where then I can select more content. I can do any of the things I want to do. I can interact with objects if I want, or I can here again, I can actually just exit Curio. Thanks for stopping by.